Hello all, today we will be covering 2.3, slope and slope-intercept form. By the end of this lesson, you guys will be able to graph linear equations and write equations of lines. So we're going to start out with our slope. If you recall, the slope in our slope-intercept form equation is our m. And to find that, we take our changes in y's, so y2 minus y1, over our changes in x's, x2 minus x1. So, what is the slope of the line that passes through the given points? x1, y1 is negative 3, 7. In x2, y2 is negative 2, 4. I like to label these so that way when I see my y2, I plug in 4. I see my y1, I plug in 7, and so on and so forth. So, I have my equation. I'm going to plug in 4 minus 7. And negative 2 minus a negative 3, which ends up becoming positive. So we have negative 3 over 1, which just reduces to negative 3 as our value for our slope, m. Our next one, we have 3, 1, and negative 4, 1. I can label these x1, y1, x2, y2 if I'd like. You don't have to though. So we have 1 minus 1 over negative 4 minus 3. So we have 0 over negative 7. Which is just 0, so our slope is 0. Last example, we have 7 comma negative 3 and 7 comma 1. So we will have 1 minus negative 3 over 7 minus 7. So we have 4 over 0. Now we cannot actually divide by 0, so this slope is undefined. This is an undefined slope. Okay, so now what do these look like? You can watch a video called Slope Dude on YouTube if you want to see like a fun animated version. Here though, we have our positive slope. If our m equals a positive number, it will rise from left to right. If our m slope is a negative number, it will fall from left to right. You'll notice here, I like to think of if I have a negative slope, it's the same way as the slant of an n. If I have a 0 slope, it's a horizontal line. And if I have a vertical undefined slope, it's a vertical line. Now, this is undefined because this line is technically not a function. It itself is a vertical line, so it does not pass that vertical line test. So it has an undefined slope. So we have our slope-intercept form. You should recall from previous classes that this is y equals mx plus b, where m is our slope and b is our y-intercept. Okay? The first few problems, we simply just plug these things in. So we have y equals, m is 1/5, x plus, now they don't just say b equals here, but we know if we plot the point 0, negative 3, that is down here, that is on our y-axis, so it is y-intercept. So our y-intercept is negative 3. So we can write a y-intercept like this, or we can write it as b equals negative 3. Okay? So this next one's very similar. We will have y equals 6x plus 5 from this guy, because this 5 is our y-coordinate, where it crosses the y-intercept. All right, Now the next couple, we need to rewrite our equation in slope-intercept form, which we did this in our last chapter. Basically, all you have to do is solve for y. So you'll subtract 5x on both sides. You'll get negative 4y equals negative 5x plus 16. You'll divide by negative 4 on both sides to both terms. So you have y equals 5 over 4x minus 4. So our slope is always the thing that comes before the x. And our y-intercept is the number, the constant by itself. So it says that we need to find the slope and y-intercept. So our slope m is 5 over 4. Our y-intercept b is negative 4. Or we can write this in Math Excel. We want you to write it like this, as 0, negative 4. That stands for our y-intercept. This next one, we're going to do the same way. We're going to get y by itself, so we add 3x to both sides. So we have half y equals 3x minus 1. To get the half to go away, we can't really divide fractions, but we can multiply by the reciprocal. So multiply by 2 on both sides. So we get y equals, and then distribute the 2 through, 6x minus 2. So our slope m is 6. Our y-intercept b is negative 2, which we can also write as 0, negative 2. Now we're going to graph some things. We always start here. We always start with our y-intercept. So I'm going to plot negative 1 on my y-axis. Now our slope, negative 2 over 3, we need to do rise, up and down, over, run, side to side. So I rise, in this case we actually go down 2 because it's negative, from this point here. We go down 2 and then we run in the positive 3 direction. We can do that again from our new point. We go down 2 to the right 3. You'll notice we need a negative slope. This indeed has the same slant as an n, so we are good to go. This next one, we start with our positive 2, so I go up 2. And my slope here, it's a little tricky, there's no number out front, is negative 1. Now any number, say it was 3 over x, you could write as 3 over 1. So you would rise 3, run 1. In this case, we are going to rise negative 1, run 1. So once again, it's a negative slope. I go down 1 over 1 from the point that I just made. Plot at least 3, and then I can draw my line. Okay, next page. This next one we're going to write in slope-intercept form. Once again, that means getting y by itself, so we can subtract 5x on both sides. If your slope can be reduced, make sure to reduce it. In this case, it can't be, but just keep that in mind. Ten over 2 can be reduced to 5 though, so do that. And then go ahead and graph it. So I'm going to go up 5. 1, 2, 3, 4, 5. and then I go down 5, negative 5, positive 2. Go again, negative 5, positive 2. I have a negative slope. It's in the same direction as the n, so we are good to go. Okay, now to graph to find the intercepts. We know to find our x-intercept, the y value on the x-axis must always be 0. So, we can plug in y equals 0. So 3x equals 12. So x will equal 4. So 1 point is 4, 0. We can plot that over 4 up 0. To find the y-intercept, we know our x must be 0. So plug in x equals 0. So we have 3 times 0 minus 4y equals 12. We solve. Minus 4y equals 12 divided by negative 4. Divided by negative 4. Y must equal negative 3. So we have 0, negative 3 is another coordinate. So we plot that. This time we only need 2 points. And we can draw a line between them. So, the slope of part E. If there is no, say, 1x or anything, that means we have 0 x's. If there's no x visible, we have 0 x's. That means our slope here, our m slope, equals 0. And a slope of 0 we know is a horizontal line. So, we must have a horizontal line at 2. If you would like, you can draw a t-table where all the y values must be 2. Y always equals 2. So no matter what x value you choose, you will always have 2 as your y value. And you'll notice they're all on that line. If you have a graph of x equals a number, this means our slope is undefined. And if you recall, an undefined slope means it runs vertically. So we have a vertical line at negative 3. Once again, we can make a x, y, t table where all of our x's are negative 3 and all of our y's are another number. And you'll notice these are also all on our line that we've drawn. Okay? All right, the last two we are going to write an equation to represent the following functions. So we need to write it in the format y equals mx plus b. So we need to find our b, our y-intercept, and also our slope. So b equals 3. Our slope, I'm going to suggest that you always find where 2 of our coordinate boxes intersect. This is what I call a pretty point. So that way you're not dealing with halves like you would at this point. So I count down 2, that's negative 2, and I count positive 3. So my rise, once again, rise over run, is slope negative 2 over 3. Plug it in. Y equals negative 2 thirds x plus 3 for that line. And the last one, we have a y-intercept of -2. And we have a rise over run, 1, 2, positive. And to the right, 1, 2, positive. So our m so far is 2 over 2, but make sure, like I said, to reduce that. So our m is 1. So our equation here in slope-intercept form is y equals 1x minus 2. You could also just write this as y equals x minus 2. I'll take either of these as correct solutions. All right, have a great afternoon.